All right, first graders, happy Friday. This is like the 6th time I've tried to video this, and I keep making mistakes. Let me tell you, my brain has really been growing. As you all know, our brain grows when we make mistakes. So today is Friday, and this is your math lesson. On your schedule, it tells you that you're going to be doing page 148 and 150 in your math book. And you'll see that both of these pages have this funny little thing on here that has a rule, and it looks like a funny machine. This is called the function machine, and we're going to talk about how to use a function machine in math. So to get started, we're going to talk about going to the library. Now, when you're in 2nd grade, you actually get to go on the bus and go to the library, the Orland Library, and check out books. In class, we check out books for our book boxes, right? And you have to, pick out some books, put your old ones back. Well, we're going to talk about some friends going to the library. We've got Bill, Sue, and Tina. And when they go to the library, Bill goes to the library and he checks out 5 books. And the next week, he's able to check out 7. Sue goes to the library, and one week she checks out 9. And the next week, she's able to check out 11 books. Tina goes to the library and she checks out 2 books. And the next week, she checks out 4. The library has a rule about checking out books. Can you tell what the rule is by these numbers? What is the rule the library has for checking out books? Do you see any patterns? Do you see what's going on here? How many more books they're able to check out each week? Well, we're going to come back to this in just a minute, these numbers, but we're going to talk about that function machine. So a function machine, like all machines, has stuff that goes in, something happens inside the machine to that stuff, and it comes out as something different. Machines make all kinds of goods. Ooh, we're talking about goods and services. Machines make goods. They make goods like pencils, toothpaste, chocolate bars. You know how I love a good chocolate bar. Well, in a chocolate machine, they would have probably melted chocolate would go into the machine, and then it would be poured into little forms, and when it comes out, it would be the actual candy bar. Another machine for a candy bar might be that just the chocolate bar goes into the machine, and inside the machine is where they put the wrapper on the chocolate bar, and it comes out as your candy bar in the wrapper that we get at the store. Well, this function machine is for math. And inside of it, it can either add numbers to it or it can subtract numbers. So if I have a function machine and I go in with 3 and I come out with 4 in my machine, what is the rule that happened in my machine? What do you think? If I go in with 3, I come out bigger. So I know I've got to be adding, right? This machine has to be an adding machine. What am I adding? Well, I know you guys are so smart. You know that if I go in with 3 and I come out with 4, that I added 1. So this machine, the rule is +1. Well, we could change these numbers and it would still work, right? If I change this to a 6 and a 7, is that still true for this rule? I go in with 6, I add 1, I come out with 7. Is that still true? Yes. Every number I put in the machine is going to do the same rule. It could even be 100. I go in with 100, I add 1, I come out with 101. The rule always happens the same when I'm using the same function machine. Now, I'm going to take these numbers that we had from our library and I'm going to plug them into a T-chart. We've used T-charts before, and as a reminder, a T-chart is used to help us organize information. Today we're organizing what number we go in with and what number we come out with. So I'm going to plug those numbers in, and then we'll look at them. So we know that Bill went to the library, and he went in. The first week he checked out 5 books, and the next week he was able to check out 7. We know that Sue checked out 9, next week 11, and Tina checked out 2, and the next week 4. Well, if we plug in the numbers into here, We go in with 5, out with 7. The first thing I know for sure is that I'm going in with a smaller number and coming out with a bigger number. So that tells me it has to be an addition rule. I have to be adding something. Let's see. 5 plus what equals 7? Now I know some of you have already got that in your head. Some of you maybe used to count on. You started at 5 and counted on in your head. Maybe you needed to use your fingers. You did 5 and then counted on to 7. 5, 6, 7. Ooh, I added 2. My rule is adding 2. It's kind of a funky 2. Adding 2. Let's see, does that work for the other one? If I go in with 9, and I come out with 11, 9, 10, 11, the rule still works. Whatever number I go in with has to add the 2 and then come out with another number. That's 2 more. Well, I could still try it with some other numbers. What if someone went to the library and they checked out 13 books and they added 2? Let's see, 13, 14, 15. Oh, the next week they could check out 15 books. What if they wanted to check out 20 books? I don't know if a library would let you check out that many, but that would be so cool. 20 books, and I add 2, I would come out with 22. My rule worked for every number in my T-chart. Now, what happens though if the number you go in with is bigger than the number that you come out with? Like in our first math problem today on page 148. So I'm going to write those numbers in here and we're going to figure that one out. What's kind of funny is these are the same numbers of our library, but in different order. All right, so if I go in with a bigger number and I come out with a smaller number, I know I have to be subtracting. I have to be taking away. So this rule is going to be a takeaway one. So if I go in with 7 and somehow I end up with 5, what did I take away? I took away 2. This time the rule, instead of adding 2, is take away. So 7 take away 2 equals 5. Let's check it with the next one. The next one says I go in with 11 and I take away 2 and it equals 9. Is that true? Yes, it is. It is true. So I know that this will work. Now they gave me an in number, but they didn't give me the out. So I have to figure this one out. So if I went in with 9, what am I going to come out with? Well, I could do this. We can use these fingers. We have them. Works for me. If we have 9 and we take away 2, that leaves us with, you're right, it leaves us with 7. We could also do a bigger number. What if we went in with, let's do 20. Ooh, if I'm at 20 and I take away 2, some of you might need to use a number grid for this. Some of you can do it in your head, but if I'm at 20 and I take away 2, I know that I end up at 18. So when we have a subtraction problem, our in numbers are going to be bigger than our out numbers. When we have addition problem, addition rule for our function machine, our numbers are going to be smaller going in and bigger going out. So I hope that you have a great day and that you do your page 148 and your page 150 in your math book. We will also be revisiting the in and out rules like this next week too. So have a great Friday. Keep doing your personal best. I really miss you. We'll talk to you later. Bye.